Hello everyone, it's my honor to be here to give a presentation, and the topic of our research is the performance evaluation model for the hotels with the hierarchical network systems, and it is also an application of the hierarchical network DEA. Our report will include 4 parts, and first we talk about the background of our study. With the development of the service economy era, the proportion of the service industry has become an important indicator to measure the economic development of a country. In China's the 13th Five-Year Plan, the proportion of the service industry and the contribution of it to the national economic growth are required to be further improved. As one of the major components of the service industry, the hotel industry has a potential development. In the fierce market competition, a critical premise of the sustainable development is to make a comprehensive understanding of a hotel's operation. As we know, DEA is an important technique in the efficiency measurement. It has also been widely applied in the hotel systems, and it always provides two perspectives of the hotel systems. The first is the conventional black box. It means a set of initial input produce the final output through a production process. And the other is the network structure. The network DEA is the first to open the black box to find some internal links of DMUs. And we can know that the black box didn't explore the internal structure of DMUs, and the network structure refers to DMU as the multi-stage processes. And however, there is still a lack of the studies on the internal structure of hotel systems from the perspective of hierarchy. So we introduce the hierarchical structure into the hotel systems and improve it. Now we talk about some research about the hierarchy of DMUs. This is the research of the Rolf and the Primont and Cow. They all use the distance function model. And the next is the two research. They all use the CCR model to measure the 10 power plant with 42 subordinate power units in the Canada. In these studies, a unit at a higher level doesn't necessarily have the same number of the subordinate units. On the contrary, we focus on those of the common subunit. The first, Castley proposed two models based on weight balancing and flow balancing. However, these two models only can measure the efficiency of the whole DMU. So, Carl proposed a relational model for the hierarchical systems, and it can measure the efficiency of DMUs and all subunits. Based on the result of Carl, Zhang and Chen introduced two models based on the additive and multiplicative network DEA, and these two models can measure the overall and the divisional efficiencies of DMUs and all subunits. According to this research, we can have a general idea of the hierarchical systems. And we find that the hierarchical network system is also applicable for the hotel systems. So we build a hierarchical network system of hotels. The left is the hierarchy structure. As the character of the service industry, the performance of the hotel industry is mainly achieved by providing the consumers with the considerate service. So, the hotels benefit from the operational department, such as the occupancy, the catering, and the management department. So it is a natural hierarchical structure combined with the hotels and the operational department. As for the network structure, many studies have discussed the multi-stage processes in the hotels, such as the production and the marketing, the production and the service and the operations and the marketing stages. We can know that these processes can be nested in the all units in the hierarchy. So the combination of these two structures will meet the hierarchical network systems of hotels. In order to enrich the hotel system about its hierarchical structure, we consider the allocation of the shared input on the hierarchy of hotels. We can notice in the past, the shared input were always allocated in the multi-stage processes of the network structure. The allocation of the hierarchical structure has not been studied. And there is a three-level structure. And starting from level 1, all unit will have its allocative ratios. In other words, if DMU has a hierarchy and shared input, and then this input will be allocated vertically along this hierarchy. Combining these two structures, we can obtain the final structure for the hotel performance evaluation. There is a three levels structure. The DMU has two subunits in level 1. The left is unit 1, the right is the unit 2, and so forth. Each unit will enjoy the same two-stage processes, and shared input will be allocated vertically by the corresponding ratios. Based on the study of cow, a feature of hierarchical systems was proposed. According to that, we set some constraint about the initial input, immediate measures, the final output, and the shared input. We just talked about that. All subunits will join the allocation of shared input, so we should describe the relationships of all units on the shared input by the allocative ratios. So the alpha is the allocative ratios about the subunit, and the sum of the ratios of those subunits belonging to the same unit is 1. That is to say, the shared input of one unit will be completely distributed to its all subunits and by the corresponding ratios. This is the multiplier model we proposed, and the objective function is to maximize the overall efficiency of DMUs. And here are some constraints about the units at different levels. And here are the constraints about the units at level 2 and at level 3. Because of the multiplier model is nonlinear, so we introduce the Trans-Cooper transformation and some settings into the multiplier model to derive a linear programming model. This is the linear programming model. And here are some constraints about the different levels at level 2 and level 3. As the result of CAL, the additive property was proposed. It means that the constraint about a unit can be the sum of those of the subunit. For example, here are the constraints about the division 1 of unit 2.2 and its two subunits in level 3. If we add the two constraints about the two units in level 3, then we can find that that is equal to the constraint of the unit 2.2. So the constraint of the unit 2.2 can be deleted. Similarly, we simplify our model by removing all the constraints which can be replaced by those of the subunit. And finally, this kind of constraint will be constituted by the unit without any subunit. By solving the model, we can obtain the optimal solution and allocative ratios of the subunit on the shared input. The overall and divisional efficiencies for DMUs and subunit will be obtained. We use the DMU as an example. Firstly, we calculate the efficiencies of two stages, and then we calculate the weight for the each stage, and which can be measured as a proportion of the total input for the each stage. And finally, the overall optimal efficiency of the DMU can be obtained by the weighted sum of the divisional efficiencies. Now we talk about the relationships between a unit and its subunit on their efficiencies. We also use the DMU as an example. We can find the relationship in the hierarchy from each stage. In the efficiency of the first stage, it's the weighted sum of the subunit in level 1, and here we assume that the weight is the proportion of the of each the subunit in upper unit for their input in the first stage, and this setting is also applicable in the second stage. By expanding this formula to the all levels, we can obtain the general formula for the first stage and the second stage. And we connect the formulas of these two stages by their weight, and we can finally obtain the relationships between a DMU and its all subunit. Now we talk about our empirical study. This figure shows the evaluation index. For the production stage, we use the employee and the operational expenses as the input, where the latter is a shared input. And the output of the production stage is the capability of the hotels. And it is also the input of the service stage. And final output is the revenue. And this index applied in the all unit of the hierarchy. We furtherly collected the data about 70 international tourist hotels in Taiwan to examine our model. This is a part of the result of our model, and we can see that the overall and divisional efficiencies of DMUs and all the subunits can be obtained, and allocative ratios and of the two subunits could be obtained. According to our evaluation, we made some summary. Firstly, the overall efficiency scores of the 70 hotels are low, and the lowest is only the 0.087. And secondly, the 70 hotels also don't have the efficient scores in their divisional efficiencies. And 58 hotels have higher efficiencies in the production stage than in the service stage, and the other 12 have the opposite situation. From the perspective of hierarchy, the two departments are also poor in their efficiencies, and 44 hotels have higher efficiencies in occupancy department than the catering department, and 26 hotels have the opposite situation. About the allocative ratios, the occupancy department is lower than the catering department in the 70 hotels. We further classified the hotels according to the two types of the location and the rooms of hotels. And according to the result of the two types and the unclassified situation, there are some comments. Firstly, the average efficiency score of the occupancy department exceeds that of the catering department. And secondly, the allocative ratios of the catering department is higher than the occupancy department. For the type of the location of hotels, the hotels in Taichung are most effective because of their remarkable development in the production stage and both of the two departments. And the efficiency of those hotels in the scenic area is the lowest. Because of the those hotels are poor in their service stage, and their catering department are also weak. For the type of the rooms of hotels, the hotels with more than 500 rooms have the highest average operating efficiency, but the two stages have the large gap in the efficiencies. And furtherly, the two departments are also differ in the service stage. The hotels with less than 2,500 rooms have the lowest efficiency in two stages and two departments. Now we have a conclusion about our research. Our research introduced the allocation of shared input in the hierarchy based on the current studies for the hierarchical systems, and our model is applied in the hotel systems. Through the empirical result, the overall and the divisional efficiencies can be obtained about a hotel and its the operational department, and the allocative ratios of the occupancy and the catering department on the shared input could also be acquired. The presented report result are also in line with the current developmental requirement of the hotel industry. That's all for my report. Thank you for your listening and welcome the criticism.